Hello and welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.1, problem number 62. For this problem, it's similar in style to 61, 60, and a few others before it, but it does have an extra added layer of complexity. So it says a Norman window has the shape of a rectangle surmounted by a semicircle, surmounted meaning a semicircle is on top of the rectangle. If the perimeter of the window is 30 feet, then express the area A of the window as a function of the width x. Okay? So, similar with other types of problems, I really want to just make sure that we take enough time to set up the problem and make sure it's done just in a really calm, consistent manner, and that way the problem goes as smoothly as it can. So Norman window, right? We've got a rectangle, and then right at this point, we've got a semicircle. So that's where we have our rectangle and our semicircle. So it's width x, and they don't give us too much more information, but, well, what's the height? We don't really know, so let's just denote that as a y. And luckily, it looks like the diameter of the semicircle is also x. So that means we could say that the Norman window has radius x over 2. Okay? Another thing that they tell us is that the whole perimeter is 30 feet. So perimeter is 30 feet. And what do we want? That's another good thing to write down. Or what do we need, or anything like that. We need area, abbreviated as A, area A, as a function of width x. Okay, so one of the challenges of that is we're going to have to figure out how to get this y here in terms of x. So with other problems, we'll have to set up a few equations, and then we'll go ahead and try to get all the variables on one side, perform a substitution, and then we should have everything in terms of x. So let's go ahead and start with our perimeter part. Well, perimeter, one of the difficulties here is we only have a perimeter of part of the rectangle, right? Because I'll use a different color for this so it's easier to see. When we're taking the perimeter of the rectangle, well, we take this side, and this side, and this side, but we do not take this side here because the window actually continues on, right? And that's where the semicircle comes into play. So the perimeter only includes 3 sides of the rectangle. So let's go back to the black color. I'll have perimeter P is equal to x plus y. And then, well, let's see, what's the perimeter of a circle? Well, the perimeter is usually called the circumference, so we'll write circumference. And that is usually c equal to 2 pi r. Well, in this case, it's a half circle, so it's only going to be 1/2 times 2 pi r. So that just gives us pi r. But what is our radius? Well, it gives us the diameter as x, but the radius is always half of the diameter. So that means the radius is going to be x over 2. So I'll draw a little star here and say if r equals x over 2, then our circumference or perimeter, right, of this half circle is going to be pi x over 2. Okay. So the total perimeter of this Norman window is going to be x plus y plus pi x over 2. Okay, let's go ahead and simplify it just a tiny bit. And let's see. Let's go ahead and get x plus 2y plus pi x over 2. Okay. And we could technically get the x's together as well, but let's not do that just for now. If we have to, we will, but let's move on to the next part. So the area of this, well, the area of any rectangle is going to be length times width. So the area A is going to be equal to x times y. And well, what's the area of a circle? I'll draw that down here. So area of a circle is area A equal to pi r squared. But in this case, we have half a circle, right? So that means that the area A is going to be equal to 1/2 pi r squared. But even more, right? We want to get rid of those terms in r and put them in x. That way we have fewer variables. So we need to remember that the radius is equal to x over 2. So the area A is equal to 1/2 pi times x over 2 squared. Well, anytime we square a fraction, that power goes to both the numerator and the denominator. So now we have area equals 1/2 pi x squared over 4. And now we can multiply over our 2 to 4 and the x to the 1. So that will give us area equal to x squared over 8 times pi. And that will finally be equal to pi x squared over 8. And that's going to be the area of our semicircle for this Norman window. So the area is going to be xy plus pi x squared over 8. Okay, excellent. Now, it's a lot to keep track of, right? But there's one other piece of information that they gave us. And they told us that the perimeter of the window is 30 feet. So I'd like to pull this perimeter equation here and bring it down. Just so I don't lose it, I'm going to box this area equation in red, just so we can find it quickly. Okay, so we are told that the perimeter, just to make sure, it says 30. Yes, okay. So it tells us that 30 is equal to x plus 2y plus pi x over 2. And they want this in terms of x. So that means we need to get y all by itself, so we could substitute it into another equation. Because yes, it says that express the area as a function of width x. Okay? So let's go ahead and get started with getting y all by itself. The first thing that I want to do, this might be a little bit of an OCD thing to do, but I would like to switch the left and right side really quick, just to get y on the left side. I always like putting variables on the left side when we have to isolate them. So we have x plus 2y plus pi x over 2 equals 30. Excellent. Okay, and let's go ahead and get started with getting y all by itself. So now we have, we'll subtract pi x over 2 minus pi x over 2. And that gets us x plus 2y equals 30 minus pi x over 2. Now we'll also subtract x over on both sides. And now we have 2y equals 30 minus pi x over 2 minus x. Okay, and now we have to divide everything by 2. And now we have y is equal to 30 minus pi x over 2 minus x all over 2. And your teacher might not want you to simplify this. Maybe they will want you to simplify it. So basically what I'll say now is if they don't want you to simplify the problem, if they don't care, then you're pretty much done there, and you can take the y here and you can just go ahead and substitute all of that in for your area function with the y right here. If your teacher really likes things simplified, then go ahead and keep watching, because we will go ahead and simplify it and we'll plug it all in to get the final answer. So just wanted to give you that disclaimer because it might take some more time to simplify it all. So first things first, let's get all of the numerator terms together. So I'd like to multiply this 30 by 2 over 2. And then I would like to multiply this x by 2 over 2. So that gives us 60 over 2 minus pi x over 2 minus 2x over 2. And now we can go ahead and, well, this is all over 2, right? Now to further simplify the top, we have 60 minus pi x minus 2x all over 2. Yeah, and I was just thinking for a second, we can't quite combine these the 2x and the negative pi x, because that's kind of an uncomfortable number. So anyways, and that's all over 2, which is basically the same, right? When you're dividing, you flip and multiply. So that will end up being 60 minus pi x minus 2x over 2 times 1 over 2. And there we go. We finally get 60 minus pi x minus 2x all over 4. And that's probably good enough for that. So finally we have y equals 60 minus pi x minus 2x all over 4. And we would like to simplify that. We would like to substitute that into this area function here. So I'll go ahead and zoom this out. Oh, you can see all the other problems on the other side that I did. There we go. And this area function was xy plus pi x squared over 8. And now we have to substitute in y right here. So let's get that going. We have a equals to x, and y in this case is 60 minus pi x minus 2x all over 4 plus pi x squared over 8. Oh man, well, we could just keep simplifying this. We could get this all under one term, right? Multiply the whole thing by 2 over 2 again. I don't know if that's necessary for this problem because it didn't say to simplify it. It said just to give it as a function. And if we keep simplifying more and more and more, that might just lend some room for an error. So we'll leave it at that. And that's going to be our final answer for this problem.